Okay, so welcome back to the second week of this course. So last week we ended with some of the concepts in pre-processing of the text. Okay, so what are the concepts that we covered? We covered given is a sentence, so or a document in general, a text document. How do I segment it into sentences? How do I segment it into words? We saw what are the specific issues that might arise because of various languages, and we talked about normalization, case folding, and other aspects like limitation and stemming. Okay, so these are some very standard pre-processing tasks that you might have to do on a given text in a given language. Okay, but there is another task that you might have to do in certain cases if the data that you are obtaining is a bit noisy. What I mean by noisy, there are certain spelling errors and you want to correct them for doing your analysis. So this task is called spelling correction. So what are the various problems that are involved with spelling correction, and what are the different algorithms that we will be using? So we'll start with a very simple algorithm of how do we use added distance for spelling correction in this particular lecture. Okay. So what is the problem of spelling correction? Suppose you are reading or you are seeing this text in your data, and the sentence is I am writing on behalf of, but in behalf you see only BEHAF and the L is missing. So now you want to correct this particular word to the actual word behalf. Now what is an algorithm approach of solving this problem? Okay. So in general, if you see this word like behalf, so ideally you would want to find out what are the closest words in English that might come in place of this. Okay, so what are words you can think of? I can think of probably behalf, and I can think of probably behave. Yes, and there might be some other words. Now, so when I will be talking about spelling correction, I'll talk about two different scenarios. One is isolated word error correction. That is, I'm trying to correct a word that is incorrect, but I'm not trying to use the context around it. So given the word BEHAF, I want to correct it without using what is there before and after this word. And this is called isolated word error detection. So now, so in this approach, I'll try to find the words that are closest to behalf. Okay, you see maybe behalf and behave will be two words. Now, so immediately I have a problem. So how do I define what do I mean by closest? Okay, so ideally you will say, okay, where you have some sort of match between this word and that word, but how do I further define it? So I need some sort of distance metric. How do I measure distance between one word and another word? And as per this metric, whichever two words are coming out to be closer will be called as closest. If they are coming too far, I'll not even consider that as a candidate for the correction. So ideally I want a distance metric that can give me that BEHAF and BEHLF are very close together. So we will start and we will actually use the metric called added distance, and this is one of the simplest metric that we can think of in this case. Now what is added distance? Okay, so what is my problem? I am given two strings. Okay, in general I am given two strings, one that is incorrect, another might be correct, and I have to find out what is the minimum distance between these two strings. Okay, so that's what I want to define by my concept of added distance. Now how is it defined? So minimum added distance is defined as the minimum number of added operations that I have to do for going from one string to another one. Okay, as the name says, added distance, how many edits you are making to go from one string to another string. That's how it is defined. Now immediately I will have the next question. What are all the various added operations I can make for going from one string to another string? So we will start with three basic operations that are insertion, that means I insert a character in the first string. Deletion, that means I delete a character in the first string. Or substitution, I delete or I substitute one character in the first string by another character. So these are three different operations that we will consider. So now my question would be, how many of these operations are needed to go from one string to another string. That is my added distance between two strings. Okay, so let's take a simple example. So I have the initial word is intention and the final word is execution, and I want to find out how many of these operations are required to go from intention to execution. Okay, so now if I try to see that, so what am I doing to go from intention to execution? I am first doing a deletion. I deleted I. Okay, now I substituted n with e. Again I substituted t with x. I kept e as it is. Then I inserted c. Okay, so here star means I went to null, so that is a deletion. Here null went to c, that is an insertion. Okay, then again I did a substitution, and with u, and tion remained as it is. So how many operations I needed? I needed 5 different operations. One was deletion, one insertion, and 3 substitutions. Okay. So these are the various operations that I did. Now I need to define for these operations what will be the added distance. Okay. So there are 2 different variations that I can use. In one variation, I might say that each operation has a cost of 1. So whether I am doing deletion, insertion, or substitution, each has a cost of 1. So in this case, what will be the added distance between the 2 strings? Because I have done 5 operations, each has a cost of 1, so distance will be 5. Okay. So this is called Levenstein distance. Now I may also use another variant where the substitution has a cost of 2, because this is 1 insertion and 1 deletion. So if I take substitution cost as 2, what will be the added distance between the 2 strings? So then I have 1 plus 1 for 1 insertion, 1 deletion, plus 3 times 2 for 3 substitutions, so that will be 8. Okay. So now my question is that how do I find the minimum added distance between 2 strings? So what will be an approach for doing that? So let us define it formally. What are we trying to achieve? So I am trying to search for a path. By a path I mean what are the sequence of added operations that I have to make for going from the start string to my final string. Okay. So now I can define what is my initial state, that is what is the word that I am trying to transform. So in the previous example, intention. Okay. So this is my initial state. Then what are the various operators that I am allowed to use over any of the states? I am allowed to use insertion, deletion, or substitution. These are my 3 operators. And there is one goal state, that is the final string that I am trying to get to. So it will be execution in the previous case. And I want to minimize the path cost, number of edits. I want to find out what is the minimum number of operations, or minimum path cost by which I can go from initial string to final string. Okay. So now, if you think of it in a very naive manner, what will be an approach that you might try? So I am starting with intention, and I have to reach execution. So one very naive method might be start with intention and try out all possible edit operations until unless you reach execution. Okay. So that is, I start with intention. I see, okay, if I delete one character, I can I can delete I go to n tension. Similarly, you might delete other characters. Okay. You might insert one character in the beginning, say e, or you can insert in any of the places. Or you might try to substitute one character, like e can be substituted by I can be substituted with e, and that gives you another word. And you might keep on trying all these operations until there is a point when you are at the goal string. So this might be one possible approach. Now what is one problem that you see with this approach? Okay, so don't you think you might have to travel a lot of paths that are not at all relevant for my problem? Okay, why should I keep deleting I and T, E and T, I, O, N all together in one path when this will never give me execution? Okay, so here I am trying to navigate all the possible edit operations to achieve the goal state. Okay, but this gives me a huge space. Okay, we will try to work out one simple example that how many, even if I try to find out words with additions 1 or 2, it might be the number of possibilities might be huge. So how can I make an optimal? How can I optimize this? Okay. So in this case, what would also happen? Lot of paths might end up with the same state. Okay, so I might end up with doing some insertion and another deletion that might end up in the same state I was starting with, or it might happen with one insertion, deletion, and another substitution. So again, this is unavoidable in that kind of approach, but we would like to avoid it. Further, do I really need to keep track of all of them? I need only those paths that will come between intention to execution. Okay. So the idea would be I define some sort of states and keep track of what are the shortest paths to each state, because ideally I want to find out what is the shortest distance between two strings. So there is no region that I should store all possible strings, that all possible ways of arriving from one string to another that are having a higher distance. Okay, because I want to keep the minimum distance path. So what is an approach that I will use? So for that, let us try to define it more formally. So I have two strings, x and y. X is of length n and y is of length m, and I am trying to find out the added distance from x to m, x to y. So in general, I can define some added distance matrix. So how will I define it? So let us say my definition is dij, where an element dij denotes the added distance between the first I characters of x and first j characters of y. Okay, so how many operations I need to make to go from I characters of x to j characters of y. Okay, so now as per this definition, what will be the added distance between x and y? This will be simply d and m. Okay, that means the n characters of x and m characters of y. Yes. So now question is, what kind of algorithm I should use for obtaining this particular the elements of this matrix? Okay. So there we will try to see this problem as a dynamic programming approach. Okay. So we will compute d and m in a tabular manner. In general, what do we do in dynamic programming? So whenever we have to solve a problem, we try to divide it in such a manner that I first solve the smaller problems and try to use their solutions to solve the bigger problem, so that I can avoid certain repetitions in my computations. Okay, so I will first start by solving dij for small values of I and j, and I will incrementally use that to find out finally my d and m by using the smaller values that I have already computed. Okay. So this is a bottom up approach. I first solve the very small sub problems and then I use it to solve the bigger problems. So I compute dij for small ij, and based on the smaller values that I have computed, I will compute larger values of dij. Okay, and I keep on doing that until I get d and m. So this will be the basic idea. So now what we will need to see that how should I be using the smaller computations to get the value for the larger ones. Okay. So I can define, so here I can define my dynamic programming algorithm for finding out the added distance between two strings. Okay. So now, so first we are doing the initialization. So there we are saying di0 is I and d0j is j. Now, does that make sense? What is di0? That is the distance between the I characters of x and 0 characters of y. Now what will be the distance? How many operations I have to make for going from I characters of x to 0 characters of y? And how can I do that? The only possible way of doing it efficiently is I keep on deleting each of the characters. So there will be I operations of deletion, so the cost will be I. Similarly, how do I go from 0 characters of x to j characters of y? I can do j different insertions. So that's why I can initialize as di0hi and d0j is j. Okay, that is fine. Now in general, how do I define dij in terms of the other short elements that I have already filled up? Okay, so here are 3 ways in which dij might be filled. So suppose I am trying to find out the distance between x, that is having right now I characters of x, and y, that is having j characters. Now the idea is that how do I compute dij using the smaller values of I and j. So that is how do I use di minus 1 j, dij minus 1 and di minus 1 j minus 1. So let us see in this example. So I want to use di minus 1 j. So what is di minus 1 j? So this is suppose one character. So this is my I minus 1, distance between x I minus 1 to yj, and suppose we have already computed that. What is the minimum cost between x I minus 1 characters and yj characters? Now how do I use it to find out what might be the minimum possible distance between xi and yj? So for the I characters in x, I can do a deletion. I go to xi minus 1, and then I use the distance between xi minus 1 and yj. Okay, so how can I write the distance? I can say that same distance that was between di minus 1 j, okay, plus 1 because I deleted one character from x. Is that clear? In xi, I deleted one character. I went to xi minus 1, and I have already computed distance between xi minus 1 and yj. Okay, so that is one for deletion, and this cost we already have. Similarly, how do I use dij minus 1? Same idea. So here I have x and y, x has I, y has j, and suppose I have already computed ij minus 1. So how will I compute the distance between I and j? I say the same distance that I computed between I and j minus 1 plus I inserted the jth character. Okay, so this you can think of it as insertion. So distance will be I j minus 1 and 1. Okay, and what might be the third possibility? Third possibility would be that I know what is the distance between I minus 1 j minus 1, and I am seeing whether I am substituting I with j. Okay, so there might be two ways. If these characters are the same, that means I am not having any cost, but if they are different characters, I will have a cost corresponding to the substitution. So di minus 1 j minus 1 plus 2 if the characters are not same, and 0 if they are same. Okay, so there are 3 ways in which I can write dij. It can be either di minus 1 j plus 1, dij minus 1 plus 1, or di minus 1 j minus 1 plus 2 if the characters are different, or 0 if the characters are the same. So there are 3 different ways I can define this cost. Now because we are only storing the minimum cost, I will see what is the minimum of all 3 costs, and that is what I will store as dij, and then I keep on doing this until I arrive at dnm. So that is a simple dynamic programming approach for solving this. Okay, so let us see one example now. So same example, intention and execution. Okay. So now, so we already filled up some entries here. Now, can you relate to this? What is this entry? This is my D10. So, in initialization we saw that D10 will be simply 1, because that means I can simply delete, I can delete this character and I arrive at the final substring. Starting from I, how do I go to null? I delete I. So, it's 1. Similarly, this will be 2, I can delete I and n one at a time. This will be 3, I and t and all, so on. Similarly, why this is 1 from null to e? That means I am inserting one character. Okay, null to ex, I am inserting 2 characters. So, this will be 1, 2 and so on. So, that explains all these initial entries in this table. Now, my problem is, how do I fill up the other entries in this table? So, for example, how do I fill this particular entry? Okay. So, now how did we define my dynamic programming approach? I said I will fill dij based on di minus 1j, dij minus 1 and di minus 1 j minus 1. Now, in this case, what is di minus 1j? Suppose I want to fill this element, this is my dij. What is di minus 1j? This is my I minus 1j. What is my di j minus 1? This is my I j minus 1. And what is my I minus 1 j minus 1? This is my I minus 1 j minus 1. Now, what will be the cost here? It will be minimum of all these 3 operations. So, let us find out for individual. di minus 1 j is 1 plus 1. So, this gives me 2. dij minus 1, cost between null and I am sorry, I think I wrote it incorrectly. It should be di j minus 1 and this should be the di minus 1 j. Okay, fine. So, what is di minus 1 j? That is from null to e. Okay. What is the cost? 1 plus 1, that will be 2. dij minus 1 is I to null, that is 1 plus 1, this will again give me 2, and di minus 1 j minus 1 is 0, yes, plus 2 if the 2 characters are not the same. So, here the 2 characters are I and e, they are not the same, so this will be 2. So, that means I can go from any of these paths and I have a cost of 2. So, minimum will again be 2. So, I enter here 2. Okay. So, now suppose I want to use that to find out the value here. So, now the one thing we can see, I need 3 different entries, this and this. Okay. So, what will be the cost? Minimum of 3, 3, 3, again this will be 3 here. So, like that I will keep on filling up all the table until I arrive at this element, that is my DNA. Okay. So, in general there might be more than one ways of arriving at the minimum cost. So, we will see how do we store that, but right now we can just put that cost as it is. So, if I fill up this complete matrix, this is what I will get. Okay. And you see the distance between intention execution in this case is 8. Okay. So, but you also see in this slide that for certain strings the additions might go up to 12. Okay. That is possible, but finally the additions between intention execution comes up to be 8. Okay. So, this approach gives me very efficiently what is the additions between one string and another string, and we know how to use this now. So, there is one further thing that we can do with this algorithm. So, that is again depending on my algorithm, my particular task. that is about computing alignments. Okay. So for some applications you just want to know what is the added distance between two strings, but for other applications you might also want to find out what are all the places where the edits took place. So what is the alignment? Remember the way we did the case of intention versus execution? We found out what are the actual places where insertion, deletion, substitutions are taking place. So this is what I mean by alignment, which parts are aligned to the other part in the string. So now the question is, can I modify the same algorithm to also find out what will be the various alignments in the string? Again, you will see it is very easy by using the previous algorithm that we have seen. Okay. So for some application we might need to align characters of the two strings to each other. Now we do this by keeping a sort of backtrace. So what do I mean by backtrace? So whenever I am filling out the value of dij, I can come up from either di minus 1j, dij minus 1 or di minus 1j minus 1. So whichever gives me the minimum cost, I will put a pointer that I came from either from left, from bottom or diagonal element. Okay. So whenever I am at d and m, I will again start doing a backtrace from there, which element I came here from, and I keep on doing it from starting from there until I arrive at the null characters. Okay. So every time we enter a cell, we remember where we came from, and when we reach the end, we trace back the path from the upper right corner to read all the alignment. Okay. So let us see how we will do that in this case. So suppose I was filling up this element and I know I can come from either here or here or here. All three are equally likely, so I might put all the 3 pointers. But suppose when I was here, the best possible way was this one, so I should have come from the diagonal to this element. So this is what I will store. Similarly here I will store another back pointer, and so on. So now once my edit operation is over, I have these back pointers at each and every cell. I start from d and m and keep on following my back pointers. So suppose I follow this one, I reach this cell, again I follow the pointer, I reach this cell, and so on until I reach the null characters, and that will give me the alignment of two strings. Okay. So here, so you will have alignments starting from d and m. So we will say from here I can go to this element, this element, this element. Now when I am here, it could have come from either of the 3 elements. So you might have some sort of preference. You might say, okay, whenever there are equal possibilities among all 3, I will always choose diagonal. Okay, this you might say. So you come to this element, then you go to left, then again you go down based on preference, down based on preference, down based on preference, and then that's where you get your alignment. So this is from here you can compute which characters in intention are aligned to which characters in execution. Okay. So simple idea. Whenever, so you can say these are deletion, insertion and substitution. So whichever gives you the minimum cost, you will add that pointer. If all 3 are giving you the same cost, you might add all the 3 pointers. Okay. Okay. So in general, suppose I start with a word x0 to xn. So 0 means null, xn is the complete word x, and I have the output string y0 to ym. So if I see this matrix of size n cross m, so every possible path from 0 to mn is a possible alignment. Okay. So what I am trying to find out, which path gives me the minimum possible added distance. Okay. And this as per dynamic programming approach, an optimal alignment should be composed of optimal sub-alignments. So that means whenever I am going from I to j, I can use always the optimal sub-alignments between I minus 1 j, and so on. Okay, so that's how this algorithm is designed. Okay, so if you do the backtrace, you can find out from intention, you go to execution, and what are all the places where you did insertion, deletion, and substitution. Okay, and which words you did not have to change at all. Okay, now what is the complexity of this algorithm? So let's talk about the time complexity. How much time it took? So you see, you had to fill all the n cross m entries of the matrix. So there are n cross m different things you have to do, and for each entry you need a constant number of operations. You find out minimum of 3 different distances. So there are n cross m times some constant. So the time complexity can be simply order of nm. Okay. Yes. What about the space complexity? Again, the space complexity is also the same. You are using only n cross m different elements, so that much is the space that you need. You are not using any other space. Remember, for each element you are using some other elements from the same matrix, so you are not using any additional space. So again, space complexity is n cross m. Now what about the backtrace? So that is, I am at d and m, and I want to find backtrace. The worst case can be I have to go through all the n elements in my column and n elements in my top and m elements in my first column. Okay, so in the worst case, I might have to do n plus m different operations. So this complexity is again n plus m. Okay, so you will see this is very efficient in compared to the approach that the naive approach that we were seeing earlier, that you start with the input string and try out all possibilities. This will become exponential very soon. So fine. So this is for the first lecture for this week, and in the next lecture we will start talking about certain variations of edit distance. Okay, why do I actually why should I even think of some variations, and how do we use that for finding edit distance?